right, today we're going to look at representations of functions. Let's start with functions. A function f is a relation that assigns each element x in a set D, which oftentimes we've referred to D as the domain, to exactly one element f of x in a set R, where R is called the range. So your x values, in other words, your x values are going to be what's called your domain, and your y or f of x values, those become your range. So let's take a look at a picture to maybe help understand this. So your function is like a box here. So whatever you put in, your input, your x value, goes through this function, and out pops your result, your y value or your f of x value. That becomes your output. So the function is how it changes that. Here's another example of a relation or function here. So whatever you start with, your x value, you plug that in to your function, and then you move over, and whatever that becomes, your function at that x value is your new result. So the function will change it somehow. If you put a in your function of this function f, out comes f of a. If you had some other point, say b here, if you plugged b into this function, then the output would be the function at b, f of b. All right, here's another representation of functions here. So let's figure out what these relations are, and then we'll see if we think they're a function or not. So the first one here, our domain, and remember that's our x value. These would be our x values here. And then our range, that's our output, that's our y or f of x values are there. How is this relation changing each time? Well, let's see if we can find a pattern. We got -2 going to -1, -1 going to 0, 0 going to 1, 1 to 2. It looks like this function each time is adding 1 on there. So the relation we have is that y is always going to be your x value that you start with plus 1. For example, if you were to put in an x value of 1, we would get a result of 2, and that's this one right here. So that is the relationship we got going on here. Let's try another one here. What is the relation here? Well, we got -4 going to 16. I got -3 going to 9, -2 to 4, -1 to 1. 1 also goes to 1, 2 goes to 4, 3 to 9, and so on. Pause the video and see if you can come up with what you think this relationship is. All right, let's see what you got. Looks like it. I think if you times it by itself, or in other words, squaring it, that's the relationship going on here. The output will equal the input squared. Because if you do -4 squared, you get 16. -3 squared, you get 9, and so on. So that would be our relationship here. Okay, so that brings us to this question. Are these functions? Take a second, decide what you think, and check. All right, these would in fact be functions. Yes, they are. And the reason is each output or input goes to one output. Now the second one, maybe you were a little questioning because like -4 goes to 16 and +4 also goes to 16. That's okay. You can have the same or different inputs go to the same output. What you can't have is an input go to 2 outputs. Then that's not a function. We don't know what the solution would be. But both of these are examples of functions. One last representation of functions here. We could also represent it with a graph. You've graphed before. Whatever space is covered along this horizontal axis, our x-axis, that's our domain. So the domain of this would be from this value all the way over to this value. Because that up here in our function, that's the amount covered. Our range, our output value would be along this y-axis here. So our range would span from this value all the way up. The highest it goes is up here, so that would be the top value. That would be our range of values there. All right, last thing, pause the video again here. See if you can sketch a rough graph of the outdoor temperature as a function of the time during a typical spring day. So what we mean by that, let's, just so we're kind of working the same thing here, let's start at, let's have this be 12 a.m. or midnight, and then let's go, let's say like maybe every 4 hours here, so 4 a.m., 8 a.m., we'll have this be noon, or 12 p.m., 4 p.m., 8 p.m., and then again back, we'd cycle back to midnight. So that is the time, and then over here is our temperature. Do a rough sketch of what you think this graph looks like. Okay, let's see. Hopefully you're kind of all around the same thing. Temperature at midnight probably is going to still drop a little bit on a typical day. And then when the sun comes up, now it'll start increasing throughout the day. Usually you kind of get to your highest temperature around 3 or 4 o'clock. And then again, sun starts going down and it's going to dip again. So some kind of graph like that, if you had that, that's probably a decent representation of that.